Hello everyone. Today let's solve the problem common divisors. So this was asked in basically Codeforces round 117 div 2, right? Common divisors. So what the question states, do one thing, you can just go through the question here. It's very simple to understand. Basically what I'll do, I'll just summarize the question so that it will be easier to understand, right? So yeah, first what the question states here, we have been given two strings s and t, right? So this is yes, this is t input, you can clearly see here. We have been given, so sorry, so we are solving the common devices problem, right? Sorry, I got confused here. So we are given the two strings s1 and s2. Sorry, I got confused. So this is s1 and this is s2, basically not s and t. This is s1 and this is s2. And a string x is called a divisor of string y. Again, I'm telling, just listen to this carefully. String x is called a divisor of string y if repeating x multiple times gives y. Repetition of the multiple x has to give y. Then only a string x is called a divisor of string y. This is very important, right? So we need to count how many such common divisors exist between s1 and s2. Simple, very simple, right? We just need to count how many such common divisors exists between s1 and s2. By listening to the question, you would have already guessed that this is the question. Basically we'll be making use of the, we can just make use of the hash map for this, and we have to definitely go for the GCD, greatest common divisor. In this case you would have already guessed that we would be using GCD, greatest common divisor, right? So here in this case, right, so this is one thing. So if we consider, let me consider a simple example so that we'll understand this one better. Just give me a second here. So suppose we have ABCD as divisor. So I'll just consider here ABCD, right? Suppose we have ABCD, sorry, is not ABCD is a divisor of ABCD, ABCD, right? So suppose we have ABCD, which is a divisor of this string ABCD, ABCD, this string, right? So this is fine. I hope this is clear, because repeating it twice gives the string. Here if we repeat ABCD, this one twice will give us ABCD, ABCD. I hope this is clear, easy to understand, right? So this is fine. So ABCD is a divisor of ABCD, ABCD, this one, because repeating it twice gives the string. So we want to count all such strings that can divide both s1 and s2. Here in this case, this is s1 and this one is s2, right? So we need to count all such strings that can divide both s1 and s2 in this case, right? I hope this is clear. So again saying, we just have to count all such strings that can divide both s1 and s2, right? So that can divide both s1 and s2. We need to find all, we need to count all such strings, right? I hope this is clear, easy to understand, right? So next thing, let's discuss the approach. I hope the question is completely clear, very easy to understand, right? So we saw the examples as well. They have given wonderful examples. This will be considered as s1 and this will be considered as s2. So we need to count all the strings that can divide both s1 and s2 in simple terms, right? So let's discuss the approach first by considering first example. Let me consider this example so that it will be easier to understand, right? So we need to get the output too. So whatever approach we will go with, you can just do the same thing, or you can just dry run the code afterwards. After writing the code, you can just dry run the code for example input 2 as well. You have to get the output 1. So let's discuss the approach and discuss the complexities, and then let's write the code. First let's discuss the approach. So see here, I have considered the same first example that they have given in the question, as I have said. So this one, for the string s1 we have abcd, abcd, right? For the string s2 we have the same abcd 4 times. Here you can just count abcd, 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 right? So here in this case you would have already guessed that abcd, abcd will make abcd, this one abcd first, a only abcd will make this one. If we go with this one twice, uh, this will give us abcd, abcd, right? Abcd twice will give abcd, abcd, and also abcd 4 times will give this one S2, ABCD, 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 ABCD. So this will be count 1 and this will be count 2. So the output has to be 2 for this one, right? You would have already guessed this one, right? So let's see how can we articulate the same thing in the form of code. Let's see the same here. So first step here, let's go with the step-by-step explanation here. First one, so same example I'm considering here. Don't get confused. The first step is, so here we will go with the length of S1. So the length of S1 here is 8. So this one, 1, 2, 3, 4, 5, 6, 7, 8. So the length of S1 is 8 here. And the length of S2, ABCD, is repeated 4 times, right? 4 into 4, this will be 16, quite obviously. You can just count here. ABCD 4 times. We have ABCD 4 times. So 4 into 4, quite obviously 16. So GCD of 8, 16 will be 8. So this is, we are just calculating the greatest common divisor here in this case. So the greatest common divisor of 8 and 16 will be quite obviously 8 in this case, right? So the GCD is 8. So let's move on with the next step here. First, we got the length of S1 and S2, and then we went with the further, we went calculating the GCD, right? So now GCD of 8 and 16 gave us 8. So I hope this is clear. Next step here is, we will try each length I that divides GCD length. Nothing but GCD we got here is 8, right? So in this case, we can try 1, 2, 4 and 8. So GCD itself is 8. So we can just try 1, 2, 4, 8. So what we are doing here, again I'm telling, just give me a second here. So we are trying each length I that divides the GCD length. Nothing but GCD length equals 8 here. In this case, we can consider 1, 2, 4, 8. So we can try 1, 2, 4, 8, right? So let's go with the first step here. Let's try with 1. So when I is 1, I equals 1, substring is only A. So here we have A, B, C, D, A, B, C, D, right? Here the distinct characters are A, B, C and D. First, we will try with A, this one. We will be trying with A. So we will check if A can be, A can build ABCD, ABCD. This one I'm speaking of. If only A can build ABCD, ABCD. No, right? Here, it cannot build BCD at all. Forget about this one, the duplicate ABCD. So it cannot build BCD at all. So in this case, no. So let's skip I equals 1. This doesn't, this fails miserably actually, right? Let's try when I equals 2 here. So here in this case, we got the substring AB. So B also we are considering now. First we considered only A. Now we are considering AB, right? We will check if AB can build ABCD, ABCD. So AB can build ABCD, ABCD here. In this case, no, right? So it can build only AB. CD is distinct and CD cannot be built here by the substring AB. So this also miserably fails, right? So let's skip, right? Let's skip. Let's come to the third part here. So we checked with 1 and 2. We still have 4 and 8 that is left, right? So let's try with the 4 now. This step, third step. This is the third step, and let's try with the 4. Here substring, now we have ABCD, because this one we are considering 4, right? 4 means characters, we can consider ABCD, right? So here now we will check with ABCD whether ABCD can build ABCD, ABCD. Yes, ABCD can build ABCD because ABCD is the duplicate of ABCD itself, right? So here in this case, ABCD, yes, it can match ABCD and ABCD string S1. Yes, it matches the S1. So let's repeat the ABCD 4 times here, right? Let's repeat the ABCD, this itself, let's repeat the ABCD 4 times. This matches the string S2 as well, ABCD 4 times, right? ABCD, 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 ABCD. So if you got confused here, the S1 string is just ABCD, ABCD, and S2 string is ABCD 4 times. So here in this case, it's this one matches string S1 and S2. ABCD matches string S1 and S2. So now the count is 1. So this matches S1 and S2 both, right? So now the count is 1. I equals 1. This matches S1 and S2. So right, this works basically. This step works. So now let's try with when I equals 8 means substring. When substring is ABCD, ABCD. So we have 8 here, right? We can consider 8 characters at a time. So we will go with ABCD, ABCD, and ABCD, ABCD matches this one, string S1. String S1 is also ABCD, ABCD, right? So this matches this one, and this one, string S2. Sorry, just give me a second here. What happened? Just 1 second. Yeah, we have ABCD. So here, this one ABCD, ABCD is to we have 4 times ABCD, right? ABCD, ABCD. Just give me a second here. Yeah, this we have 4 times here in this case. ABCD, ABCD is the string that we have considered here into 2. So this one into 2 will be same as string S2. This matches. Yes, this also matches. S1 matches, S2 matches. In this case, we will increment the count from 1 to 2, because this string substring matches S1 and S2, right? So here the count will be quite obviously 2, right? The count will be quite obviously 2. We are incrementing this one matched here. Only ABCD also matched, so we incremented the count from 0 to 1. Now we are incrementing the count from 1 to 2 because ABCD matched as string S1 and S2. Here the count will be quite obviously 2. So the output that we got here is 2. So the final count of valid common divisors here 2. So the output has to be quite obviously 2. So the output that we got here is 2, which is equivalent to the output that they have given for the that they have given in the example. Basically the output that they have shown in the example, so that is also 2. So the output that we got is equivalent to the output that they have given for the example 1 in the example 1 in the question, right? So this works absolutely correct in this case. Now let's discuss the complexities for the complexities of the code that we write in the future, right? So just give me a second here. So the time complexity would be big O of n plus m plus square root of GCD here in this case. So why it is big O of n plus m plus square root of this one GCD? Here n is nothing but, just give me a second here, n is nothing but here in this case length of the S1. So I'll just write here length, you just try to understand this one. M is nothing but here in this case S2 dot length, means length of the S2. So what we will check, we will check up to square root of GCD of length 1 comma length 2 here in this case, right? Divisors, these are the divisors. Basically n is nothing but S1 dot length, m is nothing but S2 dot length. We will check up to square root of GCD of length 1 comma length 2 divisors. So overall time complexity would be big of n plus m of square root of GCD for the code that we will be writing, right? So what would be the space complexity here? The space complexity would be big of k into L. So why it is k into L? K is nothing but the valid divisors here. So again, I'm just telling here, k is nothing but the valid divisors in this case. And what is L here? L is nothing but, so just give me a second here. Yeah, L is nothing but here maximum length of the smallest divisor. So L is nothing but, in short, maximum length of the smallest divisor. Uh, so yeah, we are storing the string in the hash set, right? So L is nothing but the max length of the smallest divisor. K is nothing but the number of valid divisors, and L is nothing but the max length of the smallest divisor, right? So overall time complexity would be big of n plus m plus square root of GCD, and the space complexity would be big of k into L for the code that we will be writing in the future, right? Now let's start writing the code. Now we are completely clear, right? I hope the approach and the complexities for the code that we will be writing in the future is completely clear. I hope the approach is completely clear, basically, right? Now let's start writing the code. So now let's start writing the code. Initially, I'll just go with, let let me import the utility class here. I'll just go with import java dot util dot star. This is fine. So yeah, let me go with the class. Mm, Let me name the class, give the class name common divisors. So I'll just go with common divisors. We have to find the common divisors itself, right? So this will be the proper name. This is fine. So let me quickly give here public static void main. This is fine. Yeah. So what happened to this one? So this takes directly. I didn't know this one. This is fine. So here, within the class, first what we'll do, let's create the scanner object. So we have to read the input, right? For that one, let's create the scanner object first. So I'll just give here scanner. So I'll just give sc. This one, let me consider new scanner. Let me go with system dot in. So why we are making use of the scanner object here? So we have to basically read the input. That is the reason. So the next part here is we have to read the first string from the input, nothing but s1, and also we have to read the second string s2 from the input, nothing but the s2. So I'll just consider here string. The variable name I'll just give s1. This one s1 I'll just give, we have considered scanner, this one variable sc, right? I'll just give sc dot next. This is fine. So the next step here is, let me give string s2 here. This one will be sc dot next. So this is fine, right? So after this step, so we have to store the length of the first string as well as the second string. So we have to store the length of s1 and s2 in short, right? So that's what we have to articulate it, the same thing in the form of code here. So I'll just go with the variable name length one. Len1 I'll just make use of here. In this case, this one will be s1 dot length. I hope this is clear. So the next one we need one more variable, nothing but len2 for s2 for the sorry, what am I doing here? Yeah, for the length of s2. So this is fine. So what we did in the previous step, we are just storing the length of first and second string. I hope this is clear, right? So now, as we had discussed in the approach, we have to calculate the GCD of the lengths of both string. If you remember, for the example that we considered, we went with GCD of 8 and 16, as it was ABCD, ABCD, and 4 times ABCD, nothing but 16, 8 and 16, if you remember. So we need to calculate the GCD of lengths of both strings here, nothing but in this case, we will make use of GCD length. Here I'll just give int GCD length equals GCD of length 1 and length 2. This one, length 1 and length 2, s1 dot length and s2 dot length we have given, right? We have initialized that one to s1 dot length and s2 dot length. So this one will be length 1 and length 2. Simple, right? So now let's do one thing. Let's make use of the hash set. So we will be making use of the hash set to store the unique common divisor string. So whenever we want to store the unique this thing, whether it may be variables, whether it may be values, we'll be making use of the hash set. Here in this case, I'll just go with hash set of uh, this is in the form of string, right? So I'll just give string in the angle brackets. So this will be common divisors here. This is fine. Common divisors. We have to create the new hash set. So I'll just give hash set angle brackets and parentheses. This is fine. So the next step here is we have to loop through all the possible divisor lengths up to the GCD length. A simple for loop here. As you know, I'll just give here int I equals 1. Yeah, this is fine. I less than length of the GCD, nothing but the variable we have given GCD length, right? So this is fine. Next, let's increment the I. So I hope this is completely clear. So within this for loop, we have to skip if I is not a divisor of GCD length. We have already discussed this one. Simple if condition here. If GCD length modulo I, so this is not equal to 0 here, then I'll just make use of the continue keyword, because we have to skip if I is not a divisor of GCD length. To skip, we will be making use of the continue keyword, right? So this is fine. So the next step, we will take the first I characters of S1 as the candidate divisor. So here I can write in this way. So don't get confused here. This will be string. I'll just take the variable sub here in this case. This one will nothing but the substring S1 dot let me make use of the substring here. So this one will be s1 dot substring of 0 to I. So we are just taking the first I characters of S1 as the candidate divisor. So after considering the first I characters of S1 as candidate divisor, we will check if the sub, nothing but the substring that we have considered in the line number 8. I am speaking of the line number 18. So we will check if the sub divides S1 and S2. Right, then if it is valid, then only we will add to the set. So we'll be making use of the add property of the set here. If you would have already guessed that one, right? So just give me a second here. So let's check if the subdivisors divide both divides both S1 and S2. So I'll just go with here. So here, if, let me go with is valid of sub, and one more thing, I'll just go with the S1 here. This is fine. And also is valid of, we have two strings, right? One is this one, what do you call, S1 and S2. So this will be sub comma S2. So this is fine, easy, right? So yeah, we are checking if sub divides both S1 and S2. So then if it is valid, then we have to add that one to the set. For adding this one to the set, we'll be making use of the add property, as I've said. So this will be common divisors dot add, what we will add, sub, right? So this is, I hope this is completely clear, right? Just give me a second here. Yeah, this is fine. So I hope this is completely clear till here. So now we have to print the number of valid common divisors. For that one, I'll be making use of s out or system. Oh, I have to print, I think, s out here. This will not. mm, so this one I have to type, I think. This is fine. System dot out. So this will be. Oh, I can give println as short form. Okay, this is fine. I didn't know this one. System.out.println. This one, what we have to pass, common divisors dot size we are going with, right? So I'll just go with size here. This is fine. So we are just printing the number of valid common divisors here. We have to print the this one, right? The number of valid common divisors. So this is fine. So the next step here is what we will be doing here. Let's write the function to check if the full string can be made by repeating part string. Nothing but full str and part str will be making use of, right, as parameters. So let me do one thing. Let's go with static boolean. So boolean, this one I'll just keep this one small b. So this is when this is fine. So I'll just give the name is valid. So let's pass the this one parameters, which is of the type string. So basically I'll just consider part str, and as I've said, another parameter will be full str, full string, and the part string. So this is fine within this function. So this is just the function to check if the full string or the full str can be made by repeating the part str. So this one we have to write, right? So what this states here is, so suppose if you have the string abcd abcd, we are and s1 abcd, just abcd, right? So just consider part string as abcd and full string as abcd twice, means abcd abcd. So we will be checking if the full string, nothing but abcd can be made by abcd. Yes, it can be made by just abcd, right? It is just the duplicate of abcd is repeated twice. So that's what, for that one we are writing the function here, right? So here this will be int length. I'll just consider the variable name length, part string dot length. So here I have to write the full length, man. Yeah, this is fine. So the next is, let's go with the length of the full string. We also need the length of the full string, right? So I'll just assign n to full string dot length. So this one I'm speaking of. This is fine. I hope this is clear as well. So the next step, it must be divisible. Else we have to return false. So it has to be divisible at any cost, right? So I'll just write here n modulo this one, length not equal to 0. If it is not equal to 0, means if it is not divisible, then we will return the boolean value false here in this case. I hope this is clear, right? So the next step, we will loop through the full string, nothing but full str in chunks of length, in the chunks of length. Let me write the simple for loop here. For int I equals 0, I less than n. So here I'll just give I equals I plus length. I need I equals I plus length. So I can just write on this way. Within this for loop, what we need to do, if any chunk doesn't match, then we have to return false. For that one, you would have already guessed that we will be making use of the if condition, right? So I'll just go with here if not of full string here dot, I'll just make use of the substring here, substring of I comma I plus length. This is fine. So I'll make use of here equals part str. This is fine, part string. So now within this if string, I mean within the if condition, if any chunks doesn't match, then we have to return false, as I have said. So this we have already discussed in the approach. So I'll just return false in this case. Else, if all the chunks matches, means ABCD matches ABCD ABCD, right? So if all the chunks matches, then let's return true here in this case. So I'll just go with return true. Else, we are returning true here. So let me come out of this function. So this is fine. So we haven't written the GCD function. We have to calculate the GCD function, right? Usually to calculate the GCD function, we will be making use of the Euclidean algorithm. You would have already guessed that one. So let's write that one very quickly. So I'll just go with static int GCD of this one, int A comma int B. This is fine. So this is just the standard GCD function. GCD function using the Euclidean algorithm. You can just call in that way, right? So this is fine. So within this function, what we will do first, we will continue until the remainder is 0. We have to continue until the remainder is 0. If you know how to calculate the GCD. So we have to continue until the remainder is 0, right? For that one, we have to continue at any cost, right? So for that purpose, we'll be making use of the while loop here. When while b not equal to 0, so within the while loop, what we will do, we have to store the remainder, we have to update a to b, and update then update b to remainder. These three steps. First, we have to store the remainder. Second thing is we have to update a to b, and the third thing is we have to update b to remainder. First, let's store the remainder. To store the remainder, I'll make use of the variable t here. In this case, I'll just give a modulo b. This is fine. After storing the remainder, we have to update a to b, nothing but here in this case a equals b, and we have to update b to remainder as well. In this case, remainder is nothing but t, right? So here this one I'm speaking of in t, whatever I have considered. So this one, we are just updating a to b and b to remainder. I hope this is clear. The last step here is, mm, if the GCD is found, then we have to return a, this one, right? So let's quickly return a here in this case. Let's quickly return a. So this is it for the, basically this is it for the code. So just give me a second here. So let's do one thing. Let's pass the input here. So I'll just come here. Let me copy the same thing here. Input this one. We have to get the output 2, right? So let me hit the run button. So here static common divisor. 1 second. Just 3. This one we have. So yeah, here let me cut this one. This one I have made mistake. So here let me paste it over here, control V. So this is fine. So now let me run. I have misplaced the bracket actually. Let me run here. So yeah, now we are getting the output 1. So here we have to get the output 2, right? Instead we are getting the output 1. Let's check what is wrong here. So yeah, here in the line number 16, what I have done is, here this has to be int I equals 1 I have given. This has to be int I less than or equal to GCD length, right? So this one, let me run this one now. I hope this works, man. Yeah. Now we are getting the output 2. So this was the mistake basically. We have to check for I less than or equal to GCD length basically, not just I less than GCD length, right? So here now we are getting the output 2, which is absolutely correct. Let's check for another input, this one. The output that we need to get here is 1, right? So let's see here. So let me run this one. Yeah, we are getting the output 1. So let's try submitting this one. Let me copy the same thing over here. Let me hit the submit button. Let me choose the problem D here, common devices, and let me paste it over here. Let me hit the submit button. I hope this works. Let's see. Let's see. So this is somewhat slow. Let's wait. So here running on test case 4. Let's wait for some time. So running on test case 8. Let's wait for some time. So it's still running on test case 45, right? So let's wait for some more time. Let's wait for some time. So here you can clearly see this got accepted, right? So whatever the code that we have written is completely correct, right? So I hope whatever we discussed is completely clear. Initially what we did, we discussed the question followed by the approach, then we discussed the complexities within the approach itself, then we wrote the code that works absolutely correct. So this got accepted, right? So I hope the solution is completely clear as per the question, right? I hope the solution is completely clear. For now, this is it. Thanks for watching, guys.